مركز التعلم الذاتي، ريادتك للتعلم. جامعة السلطان قابوس.
Performance criteria. It is not enough to say, well, I want to achieve this, to satisfy this, but after the end it will be extremely expensive, or your customer will not be happy. Okay? So we need to achieve this, but in the same time also to have to reach some goals in our activities. Okay, this is again a reminder of what you have seen. What is a logistic system? A logistic system is composed of several facilities. Facilities, very important. We will focus on facilities. Facilities, okay, that are linked with some transportation network. Okay? Any one of us has his small logistic system. Has a house where to sleep, has a shop from where he will buy things, has a library, has friends, has a football camp, sportive camp, has friends, okay? And they are linked with transportation links. He has to go from one place to another. This is in the small scale. If you go to a company society, think about a company like Toyota in order to give you a new car that is ready to be used. Think about how many facilities Toyota has and how many of these transportation connections that they have to use in order to give you a new car. About Boeing, Airbus, about Apple. About Apple, the screen is produced in one country, the other chip is produced in a completely different country, and at the end you have everything in your hand. You have the world in your hand. So this is challenging. This is difficult, extremely difficult. And designing the network is the first step in order to achieve your goals. So again, I am focusing on facilities. Facility can be any place where materials are processed, where something is done in order to get the final product. So they can be manufactured, sorted, stored, sold, consumed. Anything is done with material, sometimes even with information, just to process data and so on. It will be called facility for us. So it's like magic word that includes anything in a network like this, facility. So facility can be assembly center, manufacturing center, warehouses, distribution center from central to regional to local, transshipment points, transportation terminals, retail outlets, mail sorting centers, garbage, management whole center. All this, something is happening. We call it facility in the logistic system. Okay. During the previous 2 days, did you use only logistics or also you use supply chain? Both. Okay. Who can answer this question? You have a microphone if you want. يلا شجع. Please.
Logistics is part of the supply chain.
This is your opinion or what Dr. Al-Hajri said? He said like this or your opinion? He said like that. You have the same opinion or different? She said logistics is part of the supply chain. So supply chain is the big thing and logistics is a small thing.
Supply chain is the big thing and logistics
Is a smaller. Okay. You agree or?
Yes, supply chain is abroad. It contains many other activities.
Okay.
Logistics is one part of it.
So you have the same opinion. Okay. Okay. تفضل.
Logistics focus on the speed or the more than supply chain. to the purpose of the to provide something material from one place to another place.
Okay. Well, after teaching many years, both of them, I answered myself, what is the difference? I did some research, and I found different opinions. Some books and some scholars, you know, famous people, they think that the logistic is the big and the supply is the small. Some others, they have exactly the opposite opinion. The supply is the big, as you said, and the logistic is the subset, the small. Others, one of them is a professor in MIT. He said, honestly, I don't know the difference between the two things. So for him, logistics or supply chain is like, you know, just two different names for the same thing. Two different names for the same thing. In the book I am using for these lectures, so here we said that logistics is just some structures, facilities, linked, nothing is happening. Still nothing is going. Just I have the facilities and I have the connections. It's like having an empty airport. The airport of Muscat now is the logistic system. It is there, it is ready. So you have all the facilities, but no life there. This is the structure, the body. And this book, they are saying that the supply chain is the complex of different logistic systems that will contain also, you know, something is happening. Raw material will be moving, product, semi-finished product will be produced, final product will be produced, you know, packs will be done, and so on. So the logistic is the body, the structure, and the supply chain is the flow of things. Most of the time material and products, sometimes even information and money. Okay? So this is one of the opinions, but as I said you, sometimes just people wanted to invent a new word, so they invent a new thing that, you know, to give a new fashion to the things, but we can use supply chain and logistics in the same way. So here, each facility in the supply chain will be itself a set of different devices and subsystems. So anyone can be by itself one of the logistic systems. For example, in the plants, manufacturing plants, we will have machines, buffers, belt conveyors, all these things. Okay? In the distribution center, we will have shelves. So the thing is much more complex than what we can see in the small picture. Okay. So now, when we want to design a new network, what are the factors? What we have to take into account? Of course, it depends on the products. For example, in Muscat, how many Toyota dealers we have? Shops, showrooms. Many, صح? Hyundai, many, صح? How many of them Ferrari we have? One. And you cannot expect to have a second one. Maybe one in the whole country, not only in Muscat. في صلالة في هونداي؟ ما هونداي. Ferrari في؟ ما في. We have the representative of Dhufar. So it depends on the product, of course. It depends also on how attractive is how many competitors do you have? If there are many competitors, then you have to go as close as possible to the customer. If you don't have many, don't worry. Stay there. They will come to you. They will come to buy from you. Okay? Okay. So the first thing, have you seen this in the previous lecture? Okay. So the first is your system, we call it easily push or pull. More technically, we call it make to order or make to stock. If I am producing any product, I am producing to make stock in order to have the stock ready, then satisfy the demand, or the opposite. I am producing only if I have order. Apple is working for stock or for order? Stock. Stock. Already there are thousands, maybe millions of iPhone 8 are ready. In the stock. And they are waiting when? Today. What you are doing here? But today in America, maybe not in Oman. Even in Oman? In America. Okay. Airbus is working for stock or for order? Yeah, you cannot go to Toulouse in France and find in front of you 200 different aircrafts and you say, this is nice, I will take it with me. Of course, no. You have to make order. You know, Airbus 380, you have to wait many years in order to get your order satisfied. Okay, so this is more making to order. And these two different paradigms will completely different network, logistic network. In the first case, you need a lot of space for the warehouses. You need to go as close as possible to your customer. In the first case, no. The customer, he will make order. Maybe you need agent, maybe you need some different network, but not distribution network. Airbus, you will not find Airbus or you will find, just you have to order and that's all. Okay? So that's why we call it friendly, push and pull. The push is the make to order. That means the company is pushing the product in order to reach the customer. In the opposite case, it will be the pull. So the customer who is needing the product, and he will try to get the product directly by ordering it from the company. Push and pull. Okay? So this is the first thing. When you want to decide, you want to design your own logistic network, how many production plants, how many outsourcing, how many warehouses, how many distribution centers, how many showrooms, how many selling points in the malls. The first thing to think about is my system is push or pull. I want to produce push or a pull system. Okay? The second one is the lead time. So in any network, in any production system, there is a lead time. Lead time usually is very penalizing. It's extremely penalizing. Other logistic aspect, that paradigm that I have to take into account, who is managing the stock? Who is managing the stock? The traditional one is that the retailer, the company is managing the stock. So I am a shop. If I know that I don't have water bottles, I will place an order. And they will send me bottles. Now, and so we call this retailer managed system. And it is very costly mostly for the companies, for the customers. Now, the modern logistic systems, they are moving more and more to the vendor managed system. The vendor, he will take care of your product. He will take care of your stock. I give you an example. For example, if you go to Carrefour, if you go to Lulu, and you go, we have students that worked with us in engineering in supply chain of chicken As-Safa. You know, As-Safa, in order to make sure that these hypermarkets, they have always it is from Dhofar, no? They make sure in each of them you will find Safa representative. He's not selling. His task is not to sell or to convince you. His task is just to make sure that the products are always there. And he is always there. Maybe you cannot see him, but he is always there in all the big hypermarket. This is a vendor managed system. This is the vendor that want to make sure he will not wait for the Carrefour to make order in order to get Safa. Because maybe if the Carrefour is not managing very well his stock, probably the Carrefour will remain 1, 2, 3 hours even days without Safa, and all the customers, they will go to try to another product. Many people, they know only Safa because, Safa did many advertisement and so on. So they go without saying and take Safa. But if you don't find Safa, you will try another. And probably for any reason you can be convinced that the other is better. And next time you will not go to Safa, you will go to the other. So you are losing many customers just because your product is not available there. Okay? So this is very important, how you are managing. Now, all the modern logistic systems, there is, moreover, even for the vendor, he can coordinate better. He can coordinate better. If I will send half of truck to Nizwa, because I have a customer there, and he is asking me 3 pallets of product, of pasta. Okay? The day after, I will receive another call. Another customer from Nizwa. So the day after, I have another truck who is going again to Nizwa, and again with only half load. This is not a good coordination. If I am managing, then I will check their stock, and if I am sending a truck to Nizwa, I will satisfy all my customers there. So they will not call me the day after. They will never call me because I know when they need a product. Okay? The petrol distribution, this Oman Oil, Maha, and Shell, and now there is another one or two, Hormuz. So if you take this is another very difficult, very challenging distribution problem. Okay, and in the past, even in Oman, even now, still now, that the distribution, station, they have to call Oman Oil in order to tell them, look, I need 50,000 liters for tomorrow, super petrol or normal or whatever. It should not be like that. Now with the wireless facility, it is very easy for the company to check how much stock they have still there. And then they decide, and they will coordinate better the distribution. Okay? So this is 3. Who is managing the stock? The vendor or the customer, the retailer? 4 is the order processing technique, and the order processing technique is, in the past it was very challenging, very difficult. It takes a lot of time for the ordering of the orders. But now this issue with advances in the computer science, it has been solved. It has been solved, and now we can reduce really a lot of time of this because of the new technologies like code bars and so on, and also with modern computer facilities. Okay, the other aspect is the management of the inventory. How you are managing your inventory, your stock as a company of raw material, but also the products that are ready, input, output. So when we speak about inventory, they include the raw material, semi-finished product, and finished products. Okay? And, most of the companies in the modern logistic system, they think that stock is necessary. We should have enough stock. When I was a boy, at home, we don't used to have stock at home. We don't need, because we are close to all the small shops. There is no malls, no supermarkets. And any time we need anything, just my mother will call any of us, go, 1 liter of oil, 1 kilo of pasta, 1 kilo of bread. No need to have at home. Now it is different. Now we make our shopping from the malls. And when you go to the mall, you don't buy 1 kilo and 1 bottle. You will make shopping for the whole week, maybe for the whole month. Okay, and we need the stock. We need a place for the stock. Many years ago, people, they don't have big facilities. So anyone will have 2 dashdasha, 3 dashdasha, 2, 3 shirts, 2 trousers, and he needs just a small place. Now, everyone has 20, 30 different things to change, to show up different clothes. And this will require the space Okay? So we are needing more and more and more space in order to store our things. This is at a small scale. Think about companies. Thought about companies. So when you have a stock, you will improve the service, the level of service. You have stock, any customer will call, you will satisfy. You don't have problem. You will have always stock to satisfy them. So even if there is any unexpected peak or any event, you will be able to satisfy. You can also make the seasonal items to become available over all the year. You can produce products only, dates. The dates, they are only in small period. No, you cannot produce dates in January. صح? Okay. However, you can stock them, you organize them, you can produce them, you can produce different items and stock them in order to have dates all over the years. صح? You can also make some speculation on the price. You can buy things where the price is very low and sell them when the price is high. How you can do this? Because you have a stock. Of course, this is for products that you can stock. You cannot do it for halwa Omaniya, صح? You cannot say, I will produce 3,000 kilo of halwa Omaniya and keep it, and the day of Al-Eid, maybe if you can invent, a way of how you can say you don't use the quality of the halwa over time, and you can get it and it looks very fresh, probably you will make a lot of money. But by now you cannot do it. Because people, they know, they are expert. They know that it is not fresh and nobody will buy from you. Here there is, however, because after many years that everyone thinks that stocks is the safe things to be done, there is the Japanese philosophy that came. The Japanese philosophy. And they started to think it is the opposite. Inventory, stocks, is the root of all evils. All the problems happen, shortcomings, difficulties, because people, they just make sure that they have stock and they don't discover the weakness of your production system. They don't solve the small problems because you have stock. When the stock will be stopped, then people discover, there is something, there is problem we have to solve. But when you have stock and you satisfy all the demand, then in that time, you will discover that you have weakness in your system. Weakness in your system. So the Japanese have invented the just-in-time manufacturing. It's completely new, just-in-time. Because Japanese, they don't have space. They don't have, after the war, they lost the war, they don't have enough money. But they want to be involved in the new industry. They want to produce a car, but they don't have the American richness. They don't have money, they don't have space, they don't have resources. How to do? Just in time. Everything should be calculated. I will buy a kilo of pasta because I will cook it today. I will not keep in my house 20 kilo of pasta. In case I will need, I will take one and probably I will consume the last one after 3 months. No, everything just in time. Now, again, we like invent new names, So from the just in time, we are moving to the lean logistics. Lean logistics. By the way, PDO started now when the prices of oil started to drop. We said, we have to get involved in the lean logistics. When the prices are high, everybody is making profit. Nobody is worrying about how to improve. They don't care about improve. Okay? Now that there is problem, we have to make things efficient. Now PDO started to think about lean. Every time we meet anyone from PDO at any level, you teach logistics. Lean logistics, lean logistics. Everybody likes to apply lean logistics. In our program, master's program, all the last years, we had always only foreigners, expat students. Always. We have a master's in industrial engineering. Now these 2 years, the number of Omani people, and all of them are from petroleum, increased. And we are surprised. Subhanallah. We used to have 0 or 1 students, Omani students to do masters because they don't need, they are engineers. And being engineer in Oman, you know, you make enough money. You don't need to do master and so on. And we ask them in the interview in order to accept, why you are doing logistics? Why you are doing master? Oh, because PDU asked us to apply lean logistics. And we need to be very specialized on this. We need to have a huge, very strong background on lean logistics. Okay? So now lean logistics means even reducing the inventories because you don't have enough money. You don't have enough space. You don't have enough resources. Your money, you want to invest them elsewhere. Okay?
Excuse me?
Naam.
If we talk about a big scale like countries, for example, we have the
You know, PDO is like a country. Yeah?
yeah. For example, we have reserve food fund. You know, a big stock of rice and so on. We no need for this if we talk about the lean logistics.
Of course, you can need, but this is a very challenging. You know, you have to change completely your way of managing your system. If you have stock, you are safe. But what happens if something will happen? You need to find different channels, and the different channels you have to pay more in order to be on time. No, so everything should be very well studied, optimized, such that you will not have any delay. Of course, you can apply. Of course. A good inventory policy will take into account the significance of your products. There is a very famous classification. It is called ABC, just because we have category class A, B, and C. So in most of the companies or warehouses or stores or malls or supermarket, most of the time what you have 15 or 20% of the products, they will make for you 80% of the money. 80%. So most of the money they will come, I don't know, like Corolla for Toyota. Corolla is the most sold one. So if you take Corolla RAV4, I don't know, 3 cars, they will make for you 80% of what Toyota is selling. So of course you have to give much more importance to this. Then you will have here maybe 25, 35 of the products, they will make for you the additional 15%. And all the others, they will represent only 5%. If you go to Carrefour, just Lulu, Carrefour, any big supermarket, of course you will see that there are some products that are finishing very quickly. Very quickly. There are others, they will stay there for months and months and months waiting for somebody to remember, maybe I will not need a battery, or I will need a pump, or I need something that you will go to buy it. So this is very important. Of course, this kind of products, you give much more importance, you ensure that you have more stock, and the others you can manage them with more. It is also very important to understand how, since the beginning we said that the logistic system, facilities, and transportation links. So the transportation links is fundamental. It's very important for your logistic network in order to be efficient. And most of the time there are 3 different alternatives: private transportation, contract transportation, or common transportation. Private means your own transportation. Your own transportation. You have your own trucks, you have your own cars, you have your own trains, you have your own aircrafts. DHL is an example that is managing everything because this is their core business. The core business of DHL is the transportation and the distribution, of course, but it's the transportation. So if they don't do very well and they will try to get service from somebody else, probably they will never get the efficient service. So they're doing themselves anything. But most of the other companies, they try to reduce the investment in this kind of transportation service. So what they do, for example, they make long time contracts. Oman, for example, Shell in Oman, They have almost 100 trucks. You know, when you are traveling, you see these huge trucks, Shell. They are distributing petrol in all the country. They don't own any one of them. But they are getting them full, you know, dedicated carrier, full time for them. So they don't have to worry about the warehouse, where they have to stay, where they have to park, to pay insurance. No, this is done by the company. Okay? And there is the common transportation. Common transportation means, you know, the post, the DHL, all the other service that are, you know, common, that is not dedicated for you. Any questions so far? Further.
Some questions popped in my mind on the vendor
Management.
Yeah.
Okay.
Like if you have a company and then you have a vendor who's responsible about stuff, isn't that cost? And in logistics, you want to know
It is costly for the vendor, not for you. Because, you know, managing a stock is very costly. You will need, you know, to have everything in your Excel system. You have to.
Maybe like you said, as an example, Safa chicken.
Yes.
Like they have a representative
Yes.
each station.
Yes.
So there is a fixed cost. They have to
For-
pay those.
Yeah. But in the same time, they are making sure that the efficiency is ensured. So it is somehow, it's like that Safa that doesn't trust enough this supermarket in order to make sure that their product is always there. So what they do, okay, I will do it myself for you. This is what happens. Because when there is no Safa in Carrefour, it will not be a problem for Carrefour. The customer will go to another product. It is a problem for Safa. So I will avoid that. It is costly, but at the end, another thing, that the Safa will have a whole picture on all the points through their representative. So when they decide to go to Barca, Carrefour Barca, to serve them, they will also ask the other supermarkets around if they need a product. How is the situation? And when they go to Barca, they will try to serve many others. And they will not need to go to Barca for 2-3 days, probably. So this is very important because you are doing a kind of consolidation.
And I have another question.
Please,
on
go ahead.
petroleum station.
About?
Petroleum stations.
تفضل.
As you said, here in Oman, they have to go to themselves or
Yeah, they have to
need a
call.
or
Yes.
why don't you use forecasting? Like, yeah, we have one petroleum station here and it's busy, so they know like in 2 days they have to get a new truck there.
In normal days, you can use, of course, you can use forecasting. Okay? But when you have a football match in a SIB stadium, the consumption will be the same? No, it will be a huge peak. A huge peak. And what happens after that huge peak, if you are using only forecasting, the station will be closed for 2 days because there is no product. Okay? So you cannot manage when you have the possibility. Now it is easy. Now it is easy. You know what happens with your car? You have a sensor, like, no? And the sensor will give you the sign in front of you. And you know how much petrol. Do you think this is difficult to do for the Al-Khuda station and send their information to the Al-Fahal? No, it's extremely easy. It's very cheap. Everything can be done through internet without any cost. Just do it. Just do it. You know, once still they are not doing it. There is now, you know, the petrol when it drops, we hope that it will come back. But no, it is the chance for all the companies to improve. Because before everybody is doing a lot of money, nobody is worrying. Now there is no lot of money, you are forced to improve. You have to improve your logistics system. When you improve your logistics system, okay, then money will come, not because the oil price, but because you are operating more efficiently.
Excuse me? I have a
Further.
question. If you are a startup and you want to use one of the 3 alternatives, which one is the best?
It depends. It depends. I will come back to this point in the investment. It depends. But also, most importantly, is transportation your core business? or just is a tool for you. If your transportation is a core business, your business is all based on transportation, then you cannot give to the others your business. You have to do it yourself. This is your core business.
If I'm private and I want to do it like startup, you know, I'm start already. So I want to do it like the action. What is the best way?
I told you, this is your core business.
Yeah.
If you don't have money, don't do it. If you want to do it, you start. You should have enough money in order to have your private network.
Let's say if I went.
You know, when people think about you, Apple is one of the biggest company in the world that is spending money on transportation. One of the biggest. They spend a lot of money on transportation. But when I told you Apple, you will think about the trucks and transportation. No, you think about smartphones, computers, and so on. So what is your business? Your business is chicken, then no problem with transportation. You have to find the efficient way. Your business is computer, no problem. But if your business is transportation, you cannot give this task to others.
But if we talk like sharing economy and we use something like Uber.
This is not your business transportation. Your core business will be the computer management. It is the IT. You are not doing transportation yourself. You are doing the IT. If your IT does not work in Muscat because everybody has his car, go to Iran, go to Tehran, go to Bali, go to Jakarta. It will work, don't worry. If you have efficient one, it will work because not everybody has a car there. Your platform is useful not only in Muscat, is useful everywhere. Use it. Use it. That's all. You understand your core business. Tfadal.
Because sometimes you're supposed to use a mix of it.
Yeah, sometimes it's a mix for it. Even because sometimes you don't have, the customers, they don't have the same importance for you. So for some customers, they are very extremely important. Okay? You will use private because you control it. You can improve it. You can force it to be efficient. And some other time with other customers, even if there is some delay, no problem. If it is angry, no problem. Okay, so it depends on the customer and on the... So the channels of distribution, they can have different channels, as you can see. Sometimes it's a direct connection between manufacturer and user. When Dell started to produce computers, and people started to understand, wow, I don't need to go to the supermarket to buy Dell. Just I go to the website, I choose the characteristics, I make the order, and after 3 days I will get my Dell that I have selected at home. Dell, for a long time, it has been one of the best companies of computers because of direct connection and efficient way to do it. Some others, there are brokers, wholesalers, retailers, and you can guess how my network, logistic network, will completely change between the first way of channel and the last way. It's completely different. It's completely different. Of course, there is also the mode of transportation is very important. If you are using the ship is the slowest one, but the cheapest one. The pipeline, for example, petrol is going through the pipeline, the train, the truck, and the air. So the cost is going like this, and the speed is going the opposite direction. So if you want to have fast thing, you have to pay. If it can be slow, no problem. So the cost is very important, and many of the times we have to combine these different aspects. Now I come back to your question. One of the most important aspect is how much you want to invest. If you invest a lot of money, you will reduce the operation cost. If you have your own, if you construct your own warehouse or distribution center or production plant, you will not pay the rent every day, every year, every month. On the other hand, if you don't want or you cannot invest as a capital at the beginning, then your operation cost will be very high. If you have your own trucks, then you will just pay the maintenance and the running cost of your trucks. You will not pay money to the others in order to use their trucks. So this is very important. And of course, so this is one of the one of the examples, one of the, I give you an example. For example, when, Toyota has the second trend of big expensive cars, which is Lexus. And the same for Nissan. صح? Infinity. So when they started, Toyota, they decided that for Lexus, they will have completely different dealers, show houses. So in the mind of the people, Toyota and Lexus is not the same thing, even though they know it's the same thing. But, I am buying Lexus. It's not, okay? The Nissan, they did a different way. In the same show house, they put the normal cars of Nissan for poor people, for normal people, and they put also the Infinity in the same place. So when he goes to Nissan, he will find both, and he's not feeling that he's going to. And that's why Lexus is getting much more, one of the reasons, of course. Is this correct, or I'm wrong? Okay, so Toyota decided to invest to make a huge investment in the capital in order to have Lexus. Nissan decided, no, I will not invest more. I will use the same channels, the same dealers, the same technicians, and the same workshops. And the result that at the end, Lexus is much, much more and bigger and more, prestigious than the Nissan. So this is a decision that you have to take since the beginning. I want to invest more in the capital to reduce the operation cost, or the opposite. As a result of this is the level of service. When you invest in the capital, you can control better and get more satisfaction of your customers. And the opposite is true. So the level of service depends in the same time on the cost that you have to pay, you have to support, but also on the sales. So if I want to ensure a better level of service, it will cost me more or less? More, of course. So now, I don't know, man, probably I can guess, we have one hospital for every 10,000 inhabitants, maybe. Okay? And these hospitals are very crowded. I want to give better level of service. What I have to do? I have to construct much more hospitals. Now in Oman, just because we are in Oman, but now in Oman, if there is any fire somewhere, the average time to reach the fire from the fighting station is 8 minutes. Average. 8 minutes is a lot or not a lot? I don't know. Sometimes 8 minutes are enough to, that everybody will die and all the house will. Some other times, no. 8 minutes are nothing. 8 minutes. Okay? I want to improve. I want to give a better level of service. I want to reduce from 8 minutes to 7.5 minutes. You know how much it will cost the country? The whole country, Oman is big. Just in order to reduce from 8 minutes as average to 7.5 minutes, it will cost a lot of money, because you have to add new facilities, new stations or firefighting. And you have to decide where to locate them. And you have to decide if the previous ones are good still enough, or you have to close with them, or you have to oversize them, or you have to reduce their size. All this is network design. So look at this graph. This is the cost. And this is the level of service. Obviously, as you said, when the level of service is increasing, then the cost is increasing. So the level of service usually is a percentage. And it is the percentage of how many orders are satisfied after a target, I say, I want to satisfy Amazon. Say, I want to satisfy my customers in all the world after 2 days, for example. Okay, after 2 days. Okay, how many customers are satisfied and they get their order after 2 days? Okay, probably 75%? 50%? 100%? What is the good level of service? For you, what is the good level of service? You go to Amazon and you buy a product. Okay? You are happy if this product will reach you after how many days? 3 days. Same day. Okay, the first, I was expecting that you will tell me it depends. صح? If you are ordering medicine or you are ordering something that extremely important for you, it is not like ordering a book that you can wait. Okay? But, as you can see, it depends. One say 3 days, the other will be the same day. Okay? So, now, suppose that you want to open a new service, new business, like here, like Amazon, okay, or like Alibaba in China, and so on. Okay, where you will locate yourself? You want to be 50, or 60, or 75, or 100? 100, no, nobody goes to 100. Impossible. Nobody never go for 100. You will see why 100, no. Okay, but which one you will select? This is one of the most fundamental decisions that you have to take since the beginning, before starting. And probably the good answer is not, I want to be here. No, I close my, here, what is this? 70, okay, 70. No, you have to see all the other competitors and see where you can find the gap and place yourself there. Okay? By the way, here, there is not only one solution. There are many solutions. So what you can see in the red color, all of them are good solutions. All of them are good solutions. This will depend on your choice. When you select, for example, here this level, in this case the cost will be like this. Okay? However, it is not a good idea to select any blue point. It is always better to select the red points, all this red line, what we call efficient solutions, or technically we call them Pareto solutions, Pareto front. For example, what is better, solution 1 or solution 2, and why? Why?
It's lower cost.
They have to. علي صوتك.
Because it comes with lower cost than 2.
Yeah, so they have almost the same level of service, but this cost is much higher. So we will say that solution number 1 will dominate solution number 2. It is stupid that you will select 2, because with the same level of service you can get lower cost. Is it better 1 or 5? Of course 1. Of course 1. 1 will dominate all this rectangle. But I cannot compare 1 and 7. I cannot compare 1 and 7. Because this will represent a lower cost, but a lower service. But this, I will have here a better level of service. Yeah. So I have to decide in the beginning where I want to put my business. So you want to start a transportation. It is not a good idea always to say, okay, Amazon, not Amazon, DHL is doing it 3 days, I will do it in 2 days. Not necessarily. People is not willing to pay that much money in order to get in 2 days. It depends also which kind of product you are dealing with mainly. What happens now to sales? Because if I go to 100%, I will increase my cost, but also I will increase my sales. It's okay, I will be happy. It is not like that. Look at the sales. The sales is much more difficult because the cost it depends on you, but the sales will depend on how many customers they will approach you. Because this is just an estimation. This is the cost as we have seen before. This is the cost. And this is the sales. You can see that the cost is always increasing with the level of service. I want better level of service, I have to support highest cost. On the other hand, the sales, it will start to increase. After some time, it continue to increase, but a lower space. increase, but not too much, a lot. Okay? And after some time, I am reaching almost a saturation. I improve more, but nothing. All the customers that I expect to have, they came. Nobody can come more. Okay? So what is the good point here? What is the good level of service if I have curves like this? Of course, I am interested in the highest profit. The profit is sales revenue minus cost. Is it a good idea to be here? It will be عمل تطوعي, you know. you are volunteer, pay from your pocket in order to help others. That's all. Okay? Here, you are working just for fun. Okay? So you should be here in the maximum difference. The problem that it is very difficult to estimate this curve. This is easier. Even mathematically we can calculate it. We can make a mathematical model that will produce for you this one. But this not. It is difficult.
But
it's
you
much.
can start right from the cross point, as you say, you can start from there.
You should not. If you start by the wrong step, you will finish always with the wrong step. You have to study very well where you have to place yourself. Where you have to place yourself. This is the point. Okay, this is an example. So you can see this is the level of service. This is a company that is starting. This is the annual sales, and this is the cost. You can see that here they are very close. Not good. I am improving when the level of service is 75. Improving, but you can see here that my cost is higher than my sales. So I am losing. 100% is not good. What does it mean giving 100% in Oman or in any country of service or of firefighting? What does it mean? Yani any time there is fire, you will have immediately the car to help you. This means that you will have one car in front of every house. Ready. Exactly like what? No. There is a place where they are always ready, 24 hours. Police. No, police, they don't have firefighting. Why they should have? They have firefighting? I never said it. Huh? Yeah, this is a smart answer in the station itself. No, in every airport. There is no any airport in the world without having firefighting station. صح? In every airport they have to have that. But if you want to reach 100% of safety from fire in a country, you need to have one car firefighting in front of every house. It's like now in every car you have the new cars, you have the firefighting. The problem, they are too small. If the fire is big, it will never be enough. You have to wait for the others to help you to do it. So here, what is the best one? 85. You used your calculator or by intuition? Intuition. Okay, I will trust you. So they said 85. Okay, questions? So what we have seen now, we have seen all the factors that will push you to decide when you want to construct your own logistic system or for your company, what are the different factors that you have to take into account in order to decide which network I want to do. Okay? So let's see them very quickly. Push or pull. Push or pull. Lead time. Is it big lead time in order to get your product, or you can get it immediately? You know, sometimes you order a car and they will tell you have to wait for 1 month, even 3 months, even 4 months. Okay? If the system is managed by retailer or by the vendor, the order processing technique that is used, if you have a modern one or you have a slow one, what is the policy that you are using for the management of your stock? You need to have a big stock, so you need to have big facilities, big warehouses, big handling machines, or you need just to have a small stock just to be safe and the product will come very often. Then the transportation and the logistic manager issues. So which kind of network, everything is owned, so we call it vertically integrated. The company, when the company is owning everything, it is called integrated vertically. Otherwise, we call it outsourcing, or we call it bundling also, bundling. So you split your network. The electricity business, for example, for many years, it has been vertically integrated. So there is one company that is buying oil, that is producing oil, that is transporting oil, you know, the big transportation, the cables, and they're distributing, transporting electricity, distributing electricity, billing electricity, getting money from electricity, buying oil, all is done by one company. In the recent years, in most of the countries, including Oman, they said, why one country has to do everything? Why? So they started to split the task. There are companies for transportation, companies for distribution, companies, okay? And every company will have its own core business. Okay, so when we speak about now designing, I want to design a network, this means very simply, I want to determine my facilities. Which facilities I should have. That's all. In Oman, there is no any company that is producing wheelchairs for disabled people. Okay, I want to open. I want to open my business. I will contact 2-3 banks. I will contact some people that can help me. I can contact all the good engineers, all the accounting people, even my doctors, and I will start my business. Okay? So how many facilities I need? All in Muscat or in different places. I want to just wait for the pull system because the doctors will help me to sell my product, or I want to put all the wheelchair exposed everywhere. I will sell my wheelchairs in the pharmacies, or I will have my own shops. No? In Saudi Arabia, I have seen when you go to Umrah al-Hajj, you will see that the pharmacies, they are selling warehouses. In Europe, no. The pharmacies, they never deal with the wheelchairs. There are different shops. Okay? So the set of facilities from where the users can be served. So not only the last point for selling, but also the warehouses, the production plants, and so on. So we have to decide the number, how many production plants, how many warehouse, how many central distribution center, how many regional distribution center, how many, and so on, and so on. Okay? And so on. So if I don't put a distribution center in Shnas, what will happen? Or El Brimi, they will go to UAE, صح? They will go to Dubai, to Abu Dhabi, and they will come to Muscat to buy from me. So I have to decide. I am interested how many people are disabled that can need wheelchair in Brimi. If I guess that it is a good business for me, then I have to open their warehouse, distribution points, do advertisement, and so on. If I guess that the Brimi, they don't get married from, many diseases of disabled people because they married, the cousin and ibn ammi, ibn ammi, and so on. So if a Brimi, they have different mentality and there is no many diseases, so they don't care about that business, about that market. So the number, the location, the equipment, the size of the new facilities. I may also decide if I have a previous network and I want to increase or to introduce a new product, if I have to displace, to downsize, to increase, to divest the previous ones. So all these are kind of decisions related to the designing of the network. Suppose that I have, this is Muscat, and I want to decide, for example, only about the distribution centers. Okay? And suppose that by chance, all my customers, they are located here in Qurum. So where is a good place to have my selling point? Of course here in Qurum. I will not do it in Rui. صح? However, what happens if all my customers, they are distributed in all the big city of Muscat, reaching even Barka, Sana'a, and so on. I have customers everywhere. Where is the good place to place my selling point? Selling point is the blue point. Here it is easy. Here it is here. But when I have people distributed, customers distributed everywhere, where I have to put it? Okay. Okay. Indeed, when the companies, they were operating non-efficiently, they go to the boss. You are the boss. Or they go to the most experienced one. You have been working with our 30 years. You know everything about company. Where we have to put it? And the big wise man, he will take 2-3 hours to think, and then he will close his eyes and he will say, put it here. Okay? This is not what we want to do. At least not us in the scientific world. No, we have to do everything with, if you ask the wise one, why you selected this place, he will tell you, oh, you are not wise enough to understand my reasons. So don't ask things that you cannot understand, please. Just do it and that's all. I have been working for 40 years for this company and I know everything, so just do it. But as a student, if they will ask you, why here and not here? You need to give answer. You need to give answer. Even in normal life. Inshallah, after a few years, you will get your job. You will get your degree. You will get your job. You will get your husband, wife. You will get first children. And you start to think about your house. صح? Where to do it? Where to do it? One very easy answer. Close to my father's house. Nobody will tell you, no, you are wrong. No, this is a perfect decision. Okay? But otherwise, if you don't have your parents' house, or if your parents' house is in Dhufar and your job in Muscat, then you have to decide. You have to take decision. Where to place your house here. And you have one child who will go to this house. You are working here. Your wife is working here. The other child will work to that house. And your parents' house is here and you want to go very often to them. But also the house of your wife's parents, it is the other side. Okay? Where you will place your house? You should give an answer. This is a location. This is network design. You have your network, your point interest, and at the end you have to decide where to put your house. We have colleagues that their house, they decided to have their house far away, even in Nizwa, even in Sana'a, 100 kilometers. Okay? When they did this decision, the price of oil was 100 paisa per liter. صح? Now it is double. And what are the expectations? In 2020, كم يكون البنزين؟ كم؟ 200 paisa. Now it's 200. Now 196. In Italy, I pay 800 paisa per liter. Yes. Yes. 2 weeks ago, I did a full tank. It was 95 euro.
In 10 years' time, all cars will be electrical cars.
I'm not sure. Not because of the development, but because the petrol companies, they will stop any possibility of achieving advances in this field. It is a war. Anyway, it is a long time before reaching the Nobody will be happy to take a car that goes 60 kilometers per hour. 180? Really? Okay. What is the main difference, Shall? What is the main difference? Why we have to speak about private and public? What is the objective of the public and what is the objective, the main objective of the private? Profit. The private is working for making profit. So the main objective is to maximize the profit. What is the main objective of the public? Is the level of service. Giving a better level of service. Having more schools, more hospitals, better airports, having not crowded universities, having and so on. So in the private, the objective is the minimization of the total cost and increasing the profit, subject to some constraints that are related to the capacity. In the public sector, it is to quality of service as equal as possible in the whole population and subject to some soft budget constraints, because most of the time we say that this hospital will cost so money and it will cost the double maybe. Okay, so it's a soft, it is not really hard constraint. So when we have to face location means where to locate the places, the facilities. Okay, so when we have a new logistic system, we start like him, he wants to start his business from zero, from a thing. So he has to decide where to start. In Al-Qurum, if I will buy 1,000 meters square, it will cost me a lot of money. If I go to Barca or further, it will cost me the half, maybe the third. But on the other hand, I need to have transportation. Okay, so what is a good idea? What is a good idea? As I said before, colleagues many years ago, they decided that they work at SKU and they travel every day 100 kilometers. In Europe, nobody does like that. Nobody, impossible. Forget about it. You will spend all your salary in oil, in fuel. Nobody does like that. I know only one exception, but they put together 4 people together because they have their own house, given by the father and so on, and they stay 60 kilometers far. But they travel 4 together. If any of the 4 will change work, it is a big problem for them because even for 3, it's too costly, it's too expensive. Okay? So when things are changing, the network has to change. Has to change. Also, when you have the demand, it's changing. The demand sometimes, it is not concentrated in one space. When we are doing forecasting, as she said, we do forecasting not for the whole country. We do it, region by region, wilaya by wilaya, maybe district by district. Okay? And sometimes we see that there is big difference of products moving from one place to another. And this will force me to increase my network of distribution. When I came to Oman 6-7 years ago, what is a Khud 6? Nothing. Nothing. I remember that there is a bus that goes around to take my colleagues at the beginning, and we go to Khud 6, and we see there is only 2 different flats. One of them is for university. And we ask our colleagues, well, how we will do to do shopping? From where you can buy things? Is there any mosque to pray? No, they have to come to SKU for the prayer, Friday prayer. How is Khud 6 now? Of course, there is a whole pattern that should be changed. In few years, Khud 6, it will become maybe together with Ma'bila a new city. La? Or maybe when you have a new product that is launched, then you have to revise your network. So, this is a question for you. The network design, so the location of my facilities, is it a strategical decision or tactical decision or operational decision? You have seen the difference in the previous workshop, no? I guess. Okay? So it is strategical. Look at the definition. So the strategical decisions, you cannot change your mind only after few years. You cannot construct a house for your family And after 2 weeks or 2 months, say, no, the place is not good enough. No, I will change to another house. You cannot. Once you have your house, you have to think about, you stay there for 10 years. After 10 years, probably because you will have more 3, 4 children, it's not big enough, you can change. But this is a strategical decision for your life. The tactical decision, it's up to 1 year, 2 years. The operational decisions is day by day or week by week. So location problems, which one is this? It's mostly strategic, but sometimes it's also tactical. It depends also on the scale. If you are constructing a big warehouse, very big warehouse, it is strategical. But if you are constructing a small distribution center, it can be also tactical that you can change mind after a few years, not necessarily after tens of years. Of course, when you decide where you think about location, it will completely change also the allocation of customers. If you construct a new distribution center, then you have different customers that previously they were allocated to other distribution centers. Now you can change them and bring them to your new distribution center. And you can also attract a new demand, the new customers. So the location and the allocation, you can see the difference, no? The location is where you put your facility. The allocation is who will be served by that new facility. So these are two related problems. You have also to think about when you are solving. We are speaking about how to solve, how to solve, not by the wise, intuitive way of solving. No, scientifically. So you take a decision, and you are able to justify your decision to anyone. Okay, this is the efficiency. Modern logistics never uses the intuition. It is always based on some scientific criteria. Sometimes qualitative, most of the times are quantitative. But they are always something that is rational. You have to justify. Okay? So you have to take into account the time horizon. When you are deciding only for now, or you will decide to say, okay, now I will start by constructing one big warehouse in Rui. But let's decide what I will do after 3 years, after 6 years, after 9 years, and so on. This is a time horizon. One period or different periods over time. Okay? So when you are solving any distribution network problem for your company, you have to decide since the beginning. I will take decision one after the other, or I will take decision for many years at different stage of the time. The other is the facility topology. I will decide only on one kind of facilities. I am only deciding now where to place my warehouses. Then, finish this problem, I will decide where to place my distribution centers. Then, I will decide where to place my regional distribution centers. Or I will put all them together in the same problem. It will be huge, difficult, very challenging to solve all together in the same time. Okay? It's like when you want to construct your house, you say, okay, now I will not think about my children's school. No, I don't want to think. I cannot think about anything. I will just think about my work, my wife's work, my parents and her parents. That's all. Okay? And place myself optimally with respect to all this. Okay? If you want to do better, okay, no, I have to think about possible hospital. I will to think about the schools. I will have to think about universities. Okay? So more complex problem, less possible solutions, more costly solutions. At the end, you will not find money to construct your house that you want. It will be too expensive for you. Okay? So it depends on you how you want to when we decide about solving problems, sometimes we are happy to use some qualitative methods. So no need to go to models, no need to go to engineering algorithms and computer science implementations. just you will use some wise way to do the things. For example, what you can do is to select some possible solutions, schemes, and then study the advantage and disadvantage of each of them, and after that you decide which one is better for you. For example, one of these methods is called the weighted scoring method. So what you will do, you will, for example, this is an example, you will say, okay, now I want to select a facility, the place of facility. On the basis of what? You will say, I will have 7 different criteria: the renting cost, the availability of skilled workforce, the proximity to transportation infrastructure, the proximity to parking areas, the number of shops windows, the proximity to retail competitors, which is a bit, I want to be far away from them, and the proximity of complementary shops. Because it's very likely that if somebody wants to buy shoes, he will also want to buy clothes. So it is not a good idea if I am selling shoes to go to a place far away from anything. Nobody will come to me. They will go to a place where they will find many people selling complementary things. And you will give a score to this. For example, this is very important for you, for 40%. This is not very important. It is just 5% of your whole rating. Okay? Then after that, you will have 3 different possible sites. And you will select only one of them. This is the decision, the location decision problem. You will say, okay, site number 1, as a renting, it is 5. Good, not very expensive. This is 4. This is 4. The second one is the availability of workforce. Here, it is 3. It is not easy to find. And here is 5, very easy. It's very populated places. And here it is 5. So you will give a score. Then at the end, you will combine. You will sum these, and you will weight them by their weights. And the one that is winning, you will take it. So it is a still very easy way, but scientific way. If they will ask you why you selected this, because you have some criteria. Probably you can make some mistakes here. For example, you put this, but this is not important. For you it's so important, for your boss it is not. No problem. You make calculation again and you avoid this. Okay? So now if we go to quantitative, so using models, okay? When I say using models, maybe somebody he will escape using mathematical models. But you know, modern life is always like this. It's only based on models. You know, anyone, inshallah, when you start to work and you will have your own money, and after having your house and your good car and so on, you start to have some money in the bank. And say, why I don't invest? صح? Many people, they invest in the marketplace, صح? في البورصة. Many people, they invest. How you will do that? How you will do that? In your case, you will go to your bank, you trust them, and you tell them, okay, I will give you my money, and please manage them efficiently. So make sure that after 1 year, I will get such profit or such profit. So for you, it's easy. But the manager, the agent in the bank, he will use always mathematical models in order to manage your money. Otherwise, he will fail. He will fail. So now, anything that is efficient, it is always based on very efficient mathematical implementations, always. So I will show you something, but not, please don't escape. Or if you want to escape, go ahead, don't worry, no problem. But to show you that now, any serious problem in any field, you need to use scientific tools to do them. Now, even the doctors, in order to identify if you have some illness or no, the normal illness, he will do it because he knows how to do. But the serious things, now he's using computer. He has some data, he has some information. He will put the information in the computer and the computer will give the answer. No, the computer is doing the job. Now all the serious job is done by the computer. But of course, the computer is not. The computer needs codes, needs algorithms. Who is doing the algorithm should understand how to do it. So if you are working in a company as logistics manager, very likely, most of the time, you will have a software who will do the design for you. Okay? But the company doesn't want you to only be a consumer of the software. This is not good enough for them. So if there are two candidates, one who understands, he knows the software very well, but he doesn't know how it works, what is inside. If he wants to personalize something, he's not able. The other one, maybe he doesn't know all the aspects of the software, but he knows what is inside, the basis. They will select the second one, because the second one, with time, he will learn how to use the software. The other one, he knows how to serve the software, but if any small changes is needed, he's not able to do it. They will choose the second. The second, he knows how it's done, and if any change is needed, he will be able to do it. So let me show you just how one of these software it works. I did a huge effort to make it as easy as possible. Of course, for engineering student, it will be very easy to understand. So what do I have here? I have my customers, or my possible customers. I know where are them. I know my customers. What I want to decide? I want to decide where to locate my warehouse, or my production plant, or my retailer, or my selling point, or my show house, and so on. I want to decide the location, and this is the network design. So what I have here are known customers, but here are only potential ones. So among all these ones, I want to select one or two. I have to decide. Or I will tell the model, please, I want only to minimize the cost. So it's up to you to decide how many I need. I don't have constraint. Just I want to minimize the cost over 20 years, for example. Okay, and the connection are the material flow between this set of possible customers and this of possible warehouses or centers or facilities, and my customers. Okay, and my customers. These are there, but these are only potential. It's like this is my work, this is my wife's work, this is my parents, this is my parents, and so on. This is my network. Places the school of my son, where I have to go almost every day. And these are the possible places where I can buy house. At the end, I will not buy all of them. I buy one. This is my house, okay? So my decision will be which one I have to select in order to achieve my goals and minimize my cost, okay? Let's see it by an example. This is an example. I took it from one of the references. This is a Russian company that is producing cattle forage for farms in Russia. Okay, the company has already 7 different customers, farms. So this is a company that is producing food for the cattle, for animals, and they have already 7 different farms. So by now they are just interested in satisfy these 7 customers. And they decided, by the way, this is their demand in quintals, so 36 quintal per day. The second one, 42, 34, 50, 27, 30, and 43. Okay? So they decided to buy some silos in order to be close to the company, in order to satisfy their demand. So what they did, they identified 6 different places. 6 different places, and they want to decide which one is good enough. Of course, one of the ways to do it is to come back this to the qualitative method. To come back to this, define your criteria. You can do it by a file Excel very quickly, very easily. Okay, but we want to do better than that, more than that, even to estimate our cost. So we get much more information about that. Okay? So we will not do it like this. This is easy, and usually the quality of solution is better when we use quantitative methods. So we have the 6 different places, but each one has its own cost, fixed cost, yani how much money I have to pay to purchase, to buy it, but also the running cost, how much it will cost me to run that place. The labor is not the same. If I am far away from the workforce, I need to have transportation service to bring the customer, the workers for me. So this is first the capacity, 80, 90, and so on, till 120. These are for the 6 different possible silos that I can buy. And then I will have the second one, 350 something, and so on. So I have 6 different numbers. All of them are in euro. This is the cost for buying, for purchasing each of these 6. But I don't need 6. I will not only 1 or 2 or 3, maybe 4, in order to satisfy the demand. See the same? Moreover, I will have the operation cost. Every place has its operation cost. And the operation cost is 0.15. This is per quintal, and for every of the 6 sites. Okay? And I have also the transportation cost. The transportation cost will depend on the distance. So these are the different sites. I will select not all of them, only some of them. And these are the farms that I have to satisfy. I cannot select this. These are my customers. I have to satisfy them, 7. So the 7 farms, I have to satisfy their demand. But what I can decide is which one I have to choose. Okay? So I have here also the cost of transportation. It is 0.06 euro for every quintal and for every kilometer. Okay. Now the company decided that it will make all this calculation for 4 years. So how much it cost me for the next 4 years? So 4 years are 1,000. You know, we have 3 years with the 365 and 1 year 66. So I will have 1461 days. And now I can start to define my model. So I have the first set. The first set is the potential sites, the possible silos. Among these, I will select which one that are useful for me. I will buy them. The others, I will not buy them. My decision is based on some model. Okay? V2 are the 7 customers. So these are them. I have to satisfy all of them, or the demand. The demand is given. Okay? Okay. What I will do, I will make all my calculation on the daily cost. So I will reduce all the cost for the daily calculation. So the fixed cost, the whole one when I buy it, it will cost me 321,000 euro, and I will divide it by the number of days. So it will cost me 220 euro per day. For 4 years. For 4 years. So I am doing my management for the next 4 years. Okay? How much it will be the second one? For example. For the second silo, how much it will cost me per day? This number, this is the total number, divided by 1,461 days. صح? So then the third one is this number. Sorry, I did copy paste, so it is not very easy. But this number divided by the number of days. Then this number divided by the number of days. This number divided by the number of days. And this number divided by the number of days. This is the daily cost. Only by purchasing. Okay? It's like you buy a new car and you say, okay, how much it will cost me the new car? And you say, I will keep my car for 5 years. And I am, so 5 years is something like 1,700 days. And I am paying it 20,000 riyal. So how much every day it will cost me? This is the fixed cost. This is not the running cost, only the fixed cost. Okay? So then after that, you will see the operation cost. And the operation cost, it will include the insurance, it will include the oil, the gas, how much is using, the maintenance, and all the other aspects. Okay? This is the running cost. So this is also will be included in our case. Now we will go to the cost. You see, you need very precise calculation of your cost. This is your input. If you don't give correct input, you will never get. Please, if the paper, you finish the paper, send it back, the signature paper. Make sure that everybody has signed. Okay, please send it back. Okay, how to calculate the variable cost? The variable cost. It will be the cost of transportation and the cost of management. They are given, but they are not given. You have to elaborate to get the daily cost. Okay, the daily cost. Let's think about transportation. For example, from silo number 1 to farm number 1, how much is the distance? 80. صح? 80. How much is the cost per kilometer? It's given. 0.06. Okay? But also this cost is not only per kilometer, also per quintal. So I have to multiply this by the quantity, صح? Because the transportation will involve bigger quantity. It is here. The quantity is, no, this should be the quantity here. 80, but not that 80, this 80. No, 36, sorry, 36. The demand. The 80 is the capacity. Here I am dealing with the demand. Okay, so how much it costs me? It costs me 0.06, which is the cost per kilometer per quintal. So I have to multiply by the kilometers and by the quintals. The quintals are 36. So this is the transportation cost. 0.06 multiplied by 18 multiplied by 36. Why I have 2 here? 2 times. You have go and back. No, if you have to serve, you have to go and come back. صح? Okay. Then you have the management cost. The management cost will depend on the quantity. Is like the oil cost will depend on how many kilometers of your car. So this, the 83, is the daily cost when you are serving the farm number 1 from the site, the silo number 1. How many other parameters are there? So this is input parameter, no? How many of them? الكالكوليتر تحتاج calculator. 36 ولا 42 ولا 49 من غير calculator. It's 6 times 7. 6 times 7, 42. Because I have 6 here, I have 6 here, and 7 here. So like here I have 42. These numbers are 42. I will have 42 costs. Okay, 42 costs. The first one, we said it is C11, صح? So it is serving silo number 1, farm number 1. Then C12, C13. What is the very last one? 67 or 76? Who says 67? ارفع ايده. أنا جايك 76. Who says 67? Okay. Who says 76? The red one. 76. أنت. غيرت رأيك. So رفعت ايدك ولا ما رفعت في الأول؟ رفعت. Okay. Anybody says 76? No, because تفضل. Huh? No, we don't have 7 silos. We have 7 customers, farms, and 6 silos. So 7, 6, or 6, 7. 6, 7, yes, 6, 7. 6, 7. So it's 42, but 6, 7, not 7, 6. Okay, so I have to calculate in different way all of them. Okay, now, what are my decisions here? What I have to decide? I have to decide 2 different things. I have 6 sides, 6 silos, and I want to decide to open or not to open. So it will be yes or no. For silo number 1. Yes or no for silo number 2. How many yes or no decision are there? 6. 6. Only 6. Only 6. And if I open number 1, how much it will cost me? Number 1, daily. 220. So I have to multiply 220 by the decision yes or no. Yes or no, it is 0, 1. If it is 0, it is not counted. If it is 1, it is counted. I will open it. And I have to support the cost. That? Okay. The other decision is, if I open silos, which silo will serve which customer? It is not normal that I will open one silo that will serve also the 7 customers, and I will open another silo that are sleeping all the day. So I have to split the charge. And that's why I will serve another decision. I call it technically variable. Variable is like the x variable. You know, you remember when you solve 2x plus 1 is 10. This is the variable, x. So how much x? X is 10 minus 1 divided by 2. Here, I call it serve or not serve. It is a variable. This is what I can decide. Here the 2 is fixed, the 1 is fixed. This is input. But the x is my decision. Is the thing that I have to define, identify. It's the same here. I call it serve. So, serve is the amount of demand to be served from silo number 1 to farm number 1. What is serve 1 to? Is again the amount, and so on. How many of them I have? Again 42, like the cost. Indeed, I will multiply every variable like this by the cost, the corresponding cost that I calculated before. So now, at the end, my objective, and I am almost at the end, I will minimize the total cost. The total cost will include the fixed cost. So the fixed cost, it will be F1, which is 220, multiplied by the decision yes or no, plus F2, that I can calculate, multiplied by the decision, and so on. The decision will be defined after solving. Like here, I need to solve. صح? This is very easy. I can solve it quickly. But a model like this, you will need software to do it. Even Excel can do it for you. Okay? In the same way, like a matrix calculation. Even MATLAB can do it for you. Okay? But the variable cost, it will be the cost that we calculated before, the 83, multiplied by the variable. So if this will be 1, I have to pay this cost. If this is 0, I don't pay this cost. Okay? So how many terms like this I have? I have, of course, 42, I said. Because we have 42 costs and we have 42 variables. So each cost will be multiplied by its variable. What about the constraints? What are the limitations? You know, if I have only cost without any limitations, what will happen? I will have everything 0. Because what is the minimum of this objective function? That I don't do anything. I don't open anything. صح? You want to construct house. And they want to minimize the cost. So why you are constructing? I don't know. I just want to construct house. So what is the easiest solution? don't construct. And you don't pay anything. You want to reduce the cost. The minimum cost is 0. Just don't pay. And don't construct. But if you say, no, I have to construct because I have the family needs. I need 3 rooms. I have these restrictions. Then they will cannot be 0. I will get some different solution. Is the demand of every child must be satisfied, and the capacity of each activated silo cannot be exceeded. Okay. Are you interested to see the model, or better no?
Yes.
Huh? I don't want to have bad dreams this night because of the mathematical model, but here the yes or no, they are called Y. I have 1, 1, Y2, Y3, 4, 5, and 6. The variable that I called serve, it's called X, like this X, but I have 42 of them. The constants, they are written like this. Don't worry, just understand the principle of the thing. If you want to write it in more compact way, you don't like this very long model, you can write it like this, in a more compact way. Okay, but don't worry about it. It is difficult over for engineering students. But what about the solution? Now I have this model. This model, it is very easy once even if you don't understand it, but you can implement it to the Excel. You ask any of the engineering students, he will help you, and you solve. Click, you solve. You will get this solution. So you will activate silo number 1, 5, and 6, not the others. 2, 3, and 4, they are not efficient, not convenient for me. Then, the total cost, it will cost me for 4 years, but on the daily basis, 1,218. So all this business, it will cost me every day 1,200 in order to satisfy all the. Here I did not include the profit, the revenue, because the cost of the product is known in advance. So there is no decision there. I cannot decide. It is agreed since the beginning. So I will take care only on the things that are my decision, under my control, not the other things. Then finally, you can see from which silo I will satisfy the demand of customer number 1. 1. Customer number 2 from 6. Because this will ensure me the minimum distance. Number 3, probably because of the capacity problem, it will be satisfied 11/34 from number 1, and the remaining 23/34 from number 5. Okay? This is completely from 5, this is completely from 5, this is completely from 1, and this is completely from 1. What I will do, we will take row by row of that table and take the maximum. So for example, the first row, among all the different distances, the highest one is 738. So if I decide that I want to locate my new facility, for example, my hospital, in node number 1, then people in node number 1, they are very lucky. They have immediately very close the hospital or the school or the university or the airport. People in node number 2, they need to do 682 kilometers. People aggregated in number 3, they are quite lucky, 188. Who are the people that the most penalized ones? Are those in number 9, صح? 9. Number 9. 738. When we move to number 2, now if I will put my facility in node number 2, in vertex number 2, yani in district number 2, who will be the most penalized? The most penalized will be maybe number 3. صح? Number 3. So row by row, I will define the most penalized ones. And I will get this. If I put it number 1, then the most penalized one, it will take 738. If I put it in node number 2, the most penalized will be 841, 742. If I put it node number 4, the most penalized one, district, they have to do 700 kilometers, and so on, and so on. So now, what is my objective since the beginning? We said what we want to minimize, the penalty, the most penalized customer or district. So among all this, of course, I will select the 707 because it is the minimum among this. This is the smallest. So I know that someone will be penalized because I cannot do otherwise. I need only one place, one parking for my first aid. So someone will be happy, someone will not be happy. So I will select this, and who is the most penalized one? It's enough to come back to the table to see this 770, it is the fourth. It is number 10. So the district number 10 is the most penalized one because they need to do 770 to reach this place.
But this is considered because of the distance. What about the population?
Here, I was expecting that you ask about time, because here a distance. We can convert everything to time. You know, when we are traveling, now time is more important than distance. Okay? The population, we said that we will make aggregation of a group of people in the same to consider them as one single, as one single place. So, instead, for example, this city has been aggregated in 13 different districts. If one of the, or two or three or all of them are too big, then I can split more and more and more and more. And instead of having a table 13 by 13, I will have a table 200 by 200, or maybe 2,000 by 2,000. I will consider any single street alone. Why not? It's just Excel work. Did I answer your question?
No, I think his question is regarding if 100,000 people is located in one location, and there is only one person, it's 10 kilometers far. Yours is less.
Here somewhere we said that, I don't know if we wrote it or not, but on the basis of the population, somebody in advance did the study and considered that one place is enough. So we are not speaking about very crowded area. If it is very crowded city, of course we will not put only one. We will put many of them.
If, for example, one is located a hall, for example, there are 100,000 houses in a hall, and you are considering the whole area of city. And in Halban, maybe there is one house. So if you choose the location only as a model, then it is
صح.
you cannot
True.
sacrifice for all these 100,000 for one person.
So maybe we have, in order to improve, we have to weight them by the number of inhabitants. Or to consider al-Khud al-Sadis not only 1 point, consider it as 30 points.
But still, it is the, you are dividing one area into 13, but mostly it's the same. For example, you are having this hall, and you have another hall in College of Arts.
Yes.
In College of Arts, there's only one hall. In College of Commerce, there's 2 halls. Here, we are having 5 halls. But your concentration is part of, the main thing is the distance. And the distance would be in the center. Those 5 halls here, they have more population. So, wisely, it should be closer to this one. Because the use of the service, or the use of the project will be more in this area.
Yes, true. So my challenge here is how to keep things as simple as possible. It is a really big challenge. It's very difficult for us that we... Okay. Now, what happens if I don't have this, the directions. Of course, this is a very small network. The city, so here I have 4, but in a normal city, probably I will have 2,000 nodes, 5,000 nodes. But if we understand things for small network, then the computer will extend it for as many nodes as you want. We said yesterday that if we have a model, then the model will be solved by a computer. And for the computer, most of the time, the size now doesn't matter. Just you have to put your, to organize your model. Most of the data in all the companies are available in Excel format, and you can extend. So we are explaining for a small problem. Now, what will happen in this case? Now, my facility, my new facility, and we are still focusing only on one facility, no more, okay? It is not necessarily that I can install it here or here or here or here. It can be advantageous to put it here or here to here or here or here or here. So if I have a small network like this with 4 nodes, in the previous case, I have only 4 alternatives. 4 alternatives. In the example, we have 13 alternatives. I have 13 districts, so I will put in one of the 13 districts. Okay? But here, how many alternatives do I have? Infinity. The distance is continuous. It's continuous. So it is infinity. Here it is infinity, here is infinity, here is infinity, here infinity. So the problem, I have to select the optimum among an infinity, which is not very easy. Okay? Fortunately, many, many years ago, someone thought about solving this problem, and he got with very easy algorithm. I hope it is very easy. It is, it is not difficult, not very challenging. I made a big effort to make it as easy as possible, but please stop me and ask questions if there is any difficulty. So in this case, my facility can be in any of the different ages. So remember that we will call arc if it is like this. And we call it age if it is like this. So like this means like this and also like this. Both together is like this. So here we are in this case. Okay? So since any car can travel from here to here and from here to here, so any place can be the optimum place. Okay? The optimum place. So what I will do, we start by the notation. We will call Aij, A. This we call, for example, this is 1 and this is 2. So A12 will be the time to traverse this, to cross, to go from 1 to 2. It is not necessarily to be the shortest route. Probably the shortest route is another one that will pass by another node. Can you give me an example? Give me an example. That there is, you can follow one route, but that route is not optimal, it's not the shortest one. I'll take an example. If you want to go from Rustaq to Nizwa, which road you will do? مين منكم راح من رستاق لنزوة مرة في حياته؟ Okay, which road did you do? Okay, you used the mountain. How much time did you take? Okay, what most of the people do? Most of the people, they do this road? No, they come to Dawar Sahwa, صح? And they take the highway. صح? So the traversal, what you did is the travel, there is the road to go for traversing it, but it is not necessarily the shortest route. at least as a time-wise, okay, from the time point of view. So sometimes you will go you will go through other route in order to reduce the time. So this is exactly what will happen. We will consider two different things. The time to go directly, even though it can be very disadvantageous, and the time to go from one denotation to two, this will be the shortest route. The shortest route. Even before, when you want to go from Bushr to Al-Amrat, now there is the good way, people cross. But before that, people will go to Al-Qurum, صح? Go to Al-Qurum and take the other way because the mountain is very difficult. So this happens, that we have two different quantities. One is the direct road, and one other is the shortest. For always from the time point of view. Even in SQ, sometimes you don't go to the direct way because it is very crowded. It is very crowded. Now many people, including myself, when I am by car, I avoid to go in front of Muscat Bank branch because it's always crowded, and there is someone who decided to stop his car and stop all the other cars in order to go to the cash machine to take some money. And you are waiting there, please. I want to pass, but you cannot pass. So many people, they go the long way in order to avoid this. Okay. After that, what we will do, 1, and this is 2. A generic point here, I will call it P12. It is a point between 1 and 2. But I don't know its place. It is any point that can be there. So, to go from 1 to 2, we said you have two different ways. Either direct, so it will be 1A12, or the fastest one, the shortest one, and it will be T12. So, and when I take any point, then what will happen? I will split my distance between two different pieces of the road. So, two different pieces. I will call one of them tau 1, and the other one tau 2. So this is the time to go from 1 to this point, and this is the time to go from 2 to this point. To this point. Okay? Okay. Now, the purpose of this is to decide if my new facility will be between 1 and 2, then where is the optimum place for this P? Okay? Don't forget that when you decide to put a facility, a big facility, that will be used for the next 200, 20, 30, 40, 100 years, think about how many times people they will do that road. And if you are able to reduce that time by 10%, think about how much time, how much saving for the petrol, for the car, for the pollution, for everything you can save over the 40 years. So here we are speaking about small units if you are doing it only once by one person. But when we extend this to huge numbers, then any optimization, any small difference, even 2-3%, it will make a huge difference. Okay? And this is what we want to achieve. So even in the extension, we are trying to achieve always the optimality. I want to get the optimal operation of my system. Okay? Making things that say it works. Yeah, it works. But there are many things that work, but don't work optimally. Don't work perfectly. This is not our objective. Anyone can design a network that works. Okay? But the day after, if there is a good competitor who is acting perfectly, then you will disappear immediately because you are not able to compete. Okay? So this is the message. If you want to do any kind of business in logistics, do it optimally. Since the beginning, you will not give a chance to the others to grow. If you grow, you will grow all together, but there is no big fish and small fish. You are competitor like him. Okay, let's come back to our... so now this point, I don't know where it should be, but if I decide a priori that my facility should be here, then my objective now is to decide where. Where? Here, directly on one, or here, or here, or here, or here, or here. How I can decide? I should find some model to decide for me. I should construct the model. The model has to decide. Okay, I had to do it wisely. If anyone asks me, why you put it here? Because there you have your friend, your family, and you want to give advantage to your family. I say, no, I can justify. This is how I do it. So, how we will do this? We will consider all the other nodes. Again, as we did before, we consider all the other nodes, one by one, and I see. If I take any generic node here, 5, then from 5, I should reach this point. Again, I don't know the place of this point, but any point here. What is the most advantageous point for 5? And it is more advantageous to go through 1 or to go through 2. This is what I will answer. Okay? Let's do this short. So if you are interested we can discuss. But this is what we will do. So we will. This is 1, this is 2. Or in general, HK. Okay? HK. Now, I am going from node. This is, I will call it I. To be more general. From I, in order to reach this point, how many alternatives do I have? 2. Either I go here or I go here, صح? Okay. If I go through 1, from 1 to this point, how much time I need? How much is this? How much is this? T, not A, yeah? T, because I will take the shortest route. T, I, 1. And then plus tau 1, صح? If I go from the other way, how much time I need? T, I2 plus tau of 2. Okay? But by the way, this tau and this tau, I don't know how much exactly, because they depend on the position of this P. So this will be depend on the P. And this is the same. Okay? If I want to represent this time, it will not be a point. It is not a number. It is not a number. Why? Because this point is not well defined. When this point is here, then how much it will be the time? It will be only this. But when this point is moving, then this will increase. So I will start by this T1, I1, okay? Always to reach from I. But after that, when my point is moving, this will be increasing. صح? Okay? And when I reach point node number 2, this is node number 1, how much will be this, the maximum? It will be, as we said, T, I1 plus tau 1 of okay plus tau لا هذه one two. It will be this plus this. صح؟ لا. Will be plus A 1 2 لأن هذا كله هو A 1 2 It will be all the time to reach 1 and all the time to traverse from 1 to 2. Okay? This is the first alternative. What about the second alternative? It's to go the other way. I start from K. So I will start here somewhere. This is T, time to reach from I to 2. When I start moving like this will increase. And how much is this? T, I, 2 plus A, 1, 2. Is the time to reach from here to here, this is T, and the time to move from here to here, this is A. Now I have two alternatives, no? Either I go for him or I go from here. صح? Suppose that you are in Al-Andalus garden, no? In the mosque, in the SKU mosque. And your friend is telling me, oh, my car is damaged, please come to take me. What you will ask him? At which point, where are you? If you are closer to the Al-Khud gate, you will go from maybe engineering or linguistic center or a sports camp, صح? If he is closer to the other gate, واحة المعرفة gate, you will not go from that side, صح? You will go from the hospital side. This is exactly what we are doing. So it depends when your friend is, you will think about, is it more convenient to go from the hospital side or to go from the linguistic center side? This is exactly what we are doing. Now, what we get these two different alternatives. And we want to minimize or to maximize? Minimize. So here, since I have two alternatives, I will follow the minimum one. And here I have two alternatives. Again, I will select the minimum one. Okay? Okay. So this work is only for one of the other vertex. I will do for all the vertices. For all the vertices, I will repeat the same. Then I will put them all together. Okay? So this is for one of the vertices. I will do the same for the others, and I will get something like this. And among all this, I will take the minimum. What is this minimum? Is the place. If I decide to put it between H and K, then the best place is this. It is closer to K and not to H. But this is only for HK. Now I will repeat the same work for all the other H's. What I will get a table. And among the table, I will take the minimum. Let's see an example. So this is ambulance's place in Spain. It is a consortium of different villages. These 11 villages, they decided they don't have the possibility to have one ambulance for each of them. They are very small. They don't have budget. So they decided to be in consortium and to allocate only one ambulance to all of them. Now the problem that each of them is willing to have it in his village. Okay? What is the best way to take a decision is to take it scientifically. So they took someone who will do consultancy for him, and he has to convince everybody that it should be there. Not because of this city is bigger or more powerful or because there is some big guy there, no, scientifically. So what the first thing that they decided after some examination, they decided that only one place is enough. Okay? The probability that there is a second call while the ambulance is serving the customer is very reduced, very small. So there is no need to have more than one place, or one is enough. So we are coming back to the case of one place. Okay, one facility. Okay. Also, all the rents are two ways. Okay, so we will use the second algorithm, not the first. Okay? And we will do all our calculations supposing that the ambulance can run at the average of 90 kilometers per hour. This is an approximation, of course. It is an average. Okay? These are the 11 villages. That one is the traversal time, is the time to go from 1 to 2, from 1 to 10, from 3 to 9, and so on. Not all the villages are directly connected. For example, from 4, there is no direct connection to 11. So this arc does not exist. If you want to go from 4 to here, you have to go either from 8, 10, or 5, and so on. Okay? So what you can see there is the direct connection that is existing road between the different villages. Here, however, is the traversal time. This is the T. Okay? This is the optimum, the best route. If the connection, the best connection is the best route, then you will find the same number. For example, this 12 is the same 12 there. There is no better way. Okay? But sometimes, no, I can go through another route and I can get a better time connection. Okay. Since it is 2 directions, there is no need to repeat the same numbers here. That means that these numbers are the same here. This 12 is also here. This 18 is also here, and so on. So we just try to make it easy to read. Okay, so now if we start the first work, this work, for the node, for example, 2 and 3, for age 2 and 3, okay? So I will start for 2 and 3, node by node. We have 11, so I will consider all the other 9. And for each of the other 9, I will produce graph like this. Okay? That will give me the maximum of the minimums. This is the maximum because the most penalized one. I will put together all these 9 graphs. What I will get this. I will get this. So what is this? I call this the local center. This means that if I want to locate my new facility between 2 and 3, then the best place is to be 6 kilometers far away from 2, and this means that the most penalized other village, he will need 17 minutes in order to reach the facility. والعكس, since it is ambulance, the ambulance will need 17 minutes in order to reach that village. Okay? This is only for node 2 and for age 2 and 3. But I have to consider all the others. So I will consider all the others one by one. And for each of them, I will do this work. This is the meaning when we speak about algorithm. Algorithm, that means that you repeat the same operations many times, but with different input data. Okay? So for every one, I will reach the same result. I will have this number and this number. I will put them all in the table. By the way, the 6 and 17, they are here, between 2 and 3. And the other job will give me the other numbers. Okay? Now, this column is the distance from the first node. So for example, what is this 0, 0? Yeah. It will be the time. So here we said that if I decide to put my facility between 2 and 3, then it will be the optimum, the best place. It will be 6 minutes far away from 2, and it will take 17 minutes for the most penalized village. 0 here means that the most advantageous place is to be in 8. Okay? But in this case, the most the penalized one, it will take 13 minutes. Okay? Now I was asking him how to select the best one for all the network, not for a specific. For any specific node, arc, I know. But for the whole network, I will select the minimum with respect to this or with respect to this. I will consider this, even this time. But this is time how far you are from the node. But this is the most penalized one. So of course I will select the best one here. With respect to all these columns, the best is this. Okay? So if I will, the best solution, in order to install my ambulance or my hospital or my firefighting or airport or school, it will be in the arc between 8 and 10. It will be 2.25 minutes far from 8. So 8, they are lucky. It is not in 8. Just you go out from 8 and you find it. And among all the other nodes, the most penalized one, he needs 11.5 minutes to reach that parking place. Okay? And of course, with this optimal solution, nobody can complain because this is the scientific solution. It's not political decision. This is a scientific decision. Okay? By the way, this 11.5, it will be for these two different villages. Villanueva de la Fuente and Torre de Juan Abad. Okay. I have another kind of model, but I'm not sure if you are interested. So probably I will stop here.